You guys should have been here a couple minutes ago. So let's
We're at 2.
Alright, everyone head your paper, please. 8, 3, 2, and today we are classifying angles. Please head a paper in your math journal. Please and thank you, please. So guys, we will still be having some homework this week. I'm sorry, I know you're testing, and I know that's not as fun, but there's still important stuff that we need to learn before we take the math test next week. So I will promise you that on the days that you take the math test, there will not be math homework. I don't even think we have math class, and if we do, we'll just do some review type stuff. So, sorry that I can't give you no homework this week, but next week when we have the math test days, there will be no homework. This stuff's just so important. We got to still have our brains turned on. So, when we classify angles, we first need to know what makes an angle, right? So the world is comprised of angles, and if you've ever been interested in bridges or architecture or different things like that, you've noticed all kinds of different types of angles. One of the things that every angle has to have is vertex, right? Somewhere where lines meet. So on your notes, you can just label your notes angles or classifying angles or whatever you want. But the first thing we want to do is draw an example of an angle. And I'll do this over here just so I have exactly what I want you to have. So in your notes, please make a point. Draw 2 lines coming away from them. This is an angle. We often use an arc inside the angle to notate what we're looking at, especially if there's multiple angles together. Then, please label that the lines that make up the angle aren't lines. What are they?
Array?
It's a ray. And then this point, we already said, is a vertex. I see a lot of people not writing things down. Writing it down gets it saved in your brain much better than just looking at it. So please write these things down. Yeah. I was wondering what was going on. Can I get this back at some point, whether it's the end of the day or whenever. That is a brand new, perfect mechanical pencil. Anybody else, or are we all good? Vertex and rays. Now, a vertex can be the vertex of many different angles at the same time. Because if I have that line continued that way, or a different line coming off this way, or another different line coming off that way, there could be all kinds of different angles involved, which is why we can arc using a different number of arcs. We can arc using a different number of ticks. There are different ways that we can denote. Our most common way to denote angles is just naming it. Now, the biggest thing with naming an angle is that we have to use 3 points. So, 3-point angle notation. Please write 3-point or 3 points. This angle right here is angle, and that's our angle symbol. Anybody know how to name it? There's 2 ways that we can name it here. One is using only 1 point, but it's not very accurate, and the other is our 3-point method. This is angle ABC because the vertex has to be in the middle. The vertex has to be in the middle. Now, we could also call that just angle B. What's the problem, though, with just calling it angle B? Oh? Is it purple angle B or red angle B? Who knows? If I just say B, we don't know. But if I say A, B, C, I know what rays to use. I know what the vertex is. I know which angle it is. So that's why we use 3-point angle notation. So take a moment with your partner, decide how big is angle ABC. I'm going to clear all this stuff real quick. How big is angle ABC, and how do we know? Then, in your notes, please, well, there are going to be a few different things we write down today. I'm sorry, guys, but we got to get some learning done. I bet a lot of you already know these. The different angle types we have. Ella? Acute little angle means what? Anybody?
Less than 90.
Yeah, less than 90 degrees. What do we got to label? Marvin? Ooh, give me the next one. You know what comes next after acute? You're right, there's obtuse also, but I want to hit one between. Right, a right angle. What can a right angle measure? Only 90 degrees. Perfect 90 degrees, exactly 90 degrees. Can't be 90.1 or 89.9. Has to be exactly 90. Nathan, you with us? You got these both right now. And then Marvin, what's obtuse? Yeah, more than 90. So if we come back up to the angle ABC I asked you guys to measure, we can write angle ABC, and this means like the size of the angle. If you see that without the arc in it, it's just telling you to look at that angle, but it's not necessarily talking about the size of it. It could be, but another way that the test might show it to you is the measure of angle ABC. So if there's a little m in front of it, it just means the measure of, like, how big is it? So, you're raising your hand to tell me how big it is? All right, Ella, how big is angle ABC? But it goes through 130. You have to always make sure you start where? Start where? We have to start at a 0. So please, somewhere, right now, it doesn't even show it up here, but your protractor that you have that you should have grabbed, and if you don't, anyone need one? Possible. See how it goes. Yeah, these ones are fine. They're just smaller. You should have a 0 line. So draw an angle on your paper, or the one that you already drew with the ray up top and the vertex. Whichever protractor you have doesn't matter. There will be, so this is cracked, but it still works perfectly fine. I'll take that later. There will be a T or a hole. So the clear ones, there might be a hole at the bottom that a line goes through. That's your 0 line. The orange ones just have a T. Everybody find your center 0 point. Put that on the angle that you had drawn on your paper. Rotate your protractor. Now your spiral notebook might get in the way. Rotate your protractor to line up a 0. And then in a moment, you're going to need your book. So if you don't have a book, one of your partners should grab a book probably. Almost every day we fight the battle, and I tell you guys that you should have books, and you don't. So then you and your partner can work together, but you have to agree A, B, and C. Use your protractor and measure A, B, and C. Now that you've practiced on the one that you had, take your center 0 point, line it up on the vertex, rotate one direction. There's multiple ways that you can do it. Now you might need to extend these lines. What page are we on? Can somebody help us out? 462. Make sure you line up your 0 and then go from there. Trade off. If one partner does the first one, trade off and have the second partner do the other one. So you got to rotate. Once you line it up, make sure that you're on your 0 and that. So like, how big do you think that is? Close, because that line will be 55, so it's slightly under. Just be a little careful. You move kind of quick. Make sure you line up one of your rays on the 0 line. You guys know you're measuring these. Yeah. So when we go to measure an angle, you put this T, that guy, on your vertex. But then you have to rotate this. Say your one ray goes that way. I'm going to turn my protractor so that my 0 line on bottom ends up in the middle. 0 line. Now I have another option. I could go this way and line up that ray on the 0 line, go the other way, and that would change the number set. So since I'm on this 0 line, I use that number set. So your angle you drew will be about 85 degrees almost. The angle here at A, we got to line up on the vertex and then turn. This doesn't work because I'm on the outside of the angle, so I got to keep turning on the 0 on the outside. So I use the outside set of numbers. 30 something. So always line up your vertex and T on the bottom. Because you can go either direction. It's up to how you turn your protractor. Give me just a second. I'm going to pull the protractor up on here. All right. If you are having any issues, I don't know why that guy shrunk down. Your protractor, if you're working with an orange one, has a T that looks like this at the bottom. You want to line that up with your vertex, because that's your 0 line. What's wrong with how I'm lined up right now? Liam?
Does your degree line isn't lined up with one of the rays?
0 degree line isn't lined up with one of my rays. So I need to turn my entire protractor so that my 0 line is lined up with one of my rays. Now, make sure you're perfectly on your vertex. And a digital protractor will sometimes, guys, give me your eyes up here. You in Desmos might have an option, and we're going to work with Desmos Wednesday, Thursday, Friday. You might have an option to open an angle, and then it will actually measure for you. I doubt Desmos is going to do this, and here's a problem. Now it's telling me 34. That's wrong, right? Because on the number set that I'm actually on, I'm about 120. So for B, you should have gotten about 120 degrees. You know it's obtuse because it opens bigger than 90. And then when we line up our 0 line and our vertex correctly, we get about 120 degrees. What about A? Who can tell me what you got for A? Patrick?
Oh, about approximately 37.
About 37. Anyone verify that? Anyone get around 37 degrees? Yeah. I can even use a real protractor up on the screen. I am out of the big clear ones. No, it's all good. Oh, by the way, make sure you can read it. Everyone hold your protractor up. There is a right way and a wrong way for this to lay. On the computer, it probably won't really matter, but a physical protractor, there is upside down. And like then the numbers will be backwards, and so just be careful with that. At the bottom of the orange ones, it says view through, and you should be able to read that. So I can line up my vertex. I can line up my 0 line. And yeah, I get about 37. Depending on where I'm lined up with the vertex. We just said that B, well, that's stuck there. That's kind of interesting. B, we said, was 120. And what's C?
90 degrees.
90 degrees. All right, so let's go back and classify. Acute, right, or obtuse? A. Acute, right? It is less than 90. B. Obtuse, right? Obtuse sounds like a big name, like obtuse. 90 degrees? Just like my wife, that angle is right.
Oh, God. Smart.
All right, questions? Acute, obtuse, and right. So, talk with your partner. Jot down little notes in your notes if you want. But really just have a good conversation. Have these angles been lined up with the protractor correctly to be measured? If not, what's wrong? And chat with your partner. I forget where it goes after that. Me, a name, I call myself. Fa, a long, long way to run. So, a needle pulling thread. No, I'm perfectly fine. It's getting towards the end of the year and things don't matter. Annika, help me out with A. Is A lined up correctly? What is wrong? The point is not on the T. Now, am I on the 0 line? I am on the 0 line. So, guys, some protractors, the very bottom of it is your 0 line. So, notice this looks different than what you're using the physical handheld protractor. But this point would need to be moved to the middle. Delaney, what about B? What's up with B?
It's not set up right because isn't that line the one on the right? Yeah, that one. Shouldn't that be at the bottom?
So the whole angle would rotate, or we'd have to rotate the protractor, but we have to rotate to line up the 0 line. Oh, 0 degrees. Matt, what about C? Is your point in the middle? Are we lined up on the 0 line? Ooh, what do we need to do? Yeah, we either need to move the protractor up or move the whole angle down. The 0 line on this is the bottom. Right? We are not lined up correctly. Alex, what about D? Because they're on 60. They're on the 0 line. They're in the center. So are we lined up correctly? Yes. They read the wrong number set. So please be very careful. That's the biggest mistake we see with angle work. Lining up the angle, once you do it a few times, you're pretty good at it. It's identifying, like, take a second moment, whatever you want to say. Second guess yourself, wait, Is it obtuse? Is it acute? Does my number match what I'm thinking about how big it is? Because it's real easy to just look at the number and write down the wrong thing. So they use the wrong number set. This one, how big is it actually supposed to be? It's 120. Questions? I know today's just kind of like a little boring. We just got to get some info covered. Now, complementary and supplementary, I have a really easy way for you guys to remember. So, first, help me. First, let's write them in your notes, and then I'll give you the really easy memory trick. So, complementary angle, let's just go ahead and just label this like angle pairs to make your life easier, because then there'll be less to write. So, let's go ahead and label angle pairs. Complementary. Ramon, your hair is looking very nice today. Alex, those kicks are sweet. Nathan, you've got the coolest match room I've ever seen.
Really?
Caitlin, your hoodie is amazing.
Wow.
Grant, your shirt-on-shirt action is
Are you
fantastic.
kidding me?
To compliment someone.
Wow. That was man.
To compliment someone is the right thing to do. So complementary angles sum to 90 degrees. Together, they are right. Together, they're right. So to compliment someone is the right thing to do. How many push-ups do you guys think I can do? Somebody just say one. That's what I mean.
4,
I think
5, 6, 7, 8.
Now wait, what about my workout to be more effective? What do I do? What can I take if I want to get more muscles? Supplements make you bigger. So supplementary angles.
Good one. That was good. Okay, I'll give you props for that one.
Supplementary sum to 180. All you have to remember is it's the bigger one. There's two angle pairs, right? Complementary, supplementary. Supplement is the bigger one. It took pills, it got big. That's what supplements are, guys. Steroids aren't necessary. I mean, maybe. Like my dad takes steroids for his arthritis. So steroids have a lot of uses. I can do more push-ups if that.
You only did 8. You should
Oh,
win for
come
10.
I was just making stuff up, man. All right, so hopefully, are we okay? You seem very whispery. Is everything okay? Can we talk about that later? Did you say it's a Sharpie? It could break your face out. If it's going to, it would have already. Now it's just permanent until your skin comes off. It's only as permanent as your skin, so your skin's not permanent. Okay, so when you are asked, I know I got to stir it up, but now I got to bring you guys back. Right, Allie? Got to bring you guys back now. When you're asked to find the partnering angle for an angle, try to sketch these in your notes really quick. Just give an obtuse angle, then draw an acute angle, and then an even more acute angle, even smaller. Just sketch those out real quick. Then, if a couple of us could use your protractor to actually measure what this measures in the book, if you're faster than us and you've already got them sketched, if you can get a quick measure. Oh, what do you got for A? 130. What do you want B? 53. This is 50. This 37. So, if complementary angles get together and make a right angle, does C have a potential complementary pair? Another angle that with it makes a 90? Yeah, right? Like I could add, well, I could do the subtraction and figure it out. Can A have a complementary? No. A is too big for a complementary pair. Can A have a supplementary pair? Yeah, so let's first look at supplements. If you want to make a supplementary pair, all you have to do, make it a straight line. So on all of these, just make one of them go straight. Sorry, that one doesn't look very straight. Then we're going to compute. So if supplementaries add up to 180, let's keep using cards. Nathan, what can add with 130 to make 180? Like, how big should this angle be? 50, yeah, 50 degrees. This one's a bit harder. Grant, what do we need to add to 53 to make it supplementary? Now, make your life easy. Do the subtraction. Borrow. Seven minus 5. So we get 127 over here, right? They need to add up to make 180. Careful, guys, back there. And then what plus 37? Well, wait. Let's use a Common Core strategy here. From 37 to 40 is how far? 3. Right? Keep that in your head. From 40 to 180 is 140. So 143. Your parents don't understand that. Is the funny thing. That's why adults get all upset about the Common Core. Like, it doesn't make sense. Makes more sense than what people realize. This doesn't make sense. I'll borrow from a 10. Sorry, I'll get off my soapbox. Now, let's go back and just sketch these really fast. You don't have to have nice sketches of this. But since A doesn't have a complement, we're going to forget about A. Well, let's look at B. I should not have erased that 53. So this was 53. What needs to add with 53 to make it complementary, to make it 90? L? Oh, wait a minute. B and C are a complementary pair. Because with C, you just need to add 53. Now, complementary pairs do not have to be right against each other, right next door to each other. They can be separated. However, if they are right next to each other, this is what we call adjacent. So, real quick, because I'm running out of time, I only got 5 minutes left. And not adjacent angle, but adjacent. Now, depending on where you live, your neighbor may or may not be adjacent to you. For a long time, I had multiple neighbors adjacent to me. Adjacent means next to and touching. So if you live in a duplex or an apartment, your neighbor's walls touch your walls. So adjacent, so write down in your notes, adjacent means next to and with angles shared vertex and side. With angles, they have to have a shared vertex and side. Yeah, but with angles, it's more specific, right? It's tougher with angles. So you can't just share a wall. So think about it like this. I could have one angle going that way and another angle going that way. These are not adjacent. Because they're not sharing the same vertex. This one opens that way with a vertex here. Red angle opens this way with a vertex there. These are not adjacent. So adjacent, an example that you can put in your notes. Same side. Trying to show that it's green and blue. They should like point the same direction. So shared vertex, shared side. So if you want to put in your notes that like this angle A and B are adjacent. Shared vertex, shared side.
Jason doesn't have a Z in it.
No Z. Now also, nothing can be inside the other. So if one of the angles has eaten the other one, it is not adjacent. All right, Renaud. Sorry, I think earlier I called you wrong. Renaud. A. Are those adjacent? Yes. B. Ella, are those adjacent? No. Why not? Ah, two different vertexes. C. Eleanor, what do you think?
Yeah, they're decent.
Are you sure?
Oh, yeah,
There's overlap. So even though they do share a side, this is tough. They share a side, but there's overlap. The one is inside the other one because angle 2 is so big and angle 1's inside of it, that doesn't work. So this is not adjacent. What about D, Penelope? That's Kate, what about D? Why not? Yeah, they're not touching. Liam, E? Yes.
Yes.
And F, angles 1 and 2, Emily. Angles 1 and 2? Why? One and 2 are not next to each other, right? This is hard too because the picture, there are angles next to each other. There are adjacent angles. But here, there is a gap.
What is H?
G, Aubrey, what do you think? G? No, because there's totally a gap. Francesca, what about H? What do you think? You got a 50-50 chance. Are they next to each other, sharing side, sharing a vertex? So the issue here, they have two different vertexes. Notice how angle 1's over there and angle 2's over there. They have two different vertexes. This is a no because they have to share the same vertex. Caitlin, what about I? Do they share a vertex? They don't share a vertex? I think they both use that dot as their vertex. So they are adjacent, yeah. They do share the vertex. They do share the side right here. So this is a yes. Now last, it's amazing how many journals can flip closed without me saying, like, all right, that's it. Anything like that. Last thing you need to know. This is the last thing. Vertical angles means that they are opposite and exactly the same. I see people not writing this down. We need to be writing this down. So vertical angles, spelled C-A-L. So draw two straight lines on your paper. The top and bottom angles will always be identical because if I rotate one line, they both get bigger. Or if I rotate one line, they both get smaller. And the left and right angles are identical. So these are two different vertical pairs. So green is vertical with each other. Blue is vertical with each other. I still have, I have till 9:05. We're okay, guys. So green's vertical with each other, blue's vertical with each other. Two straight lines, the angles that are opposite each other. So, if we check these out right here, if angle 1 is 55 degrees, and go ahead and sketch this in your notes real quick, just because this is fast to do. So throw two straight lines, top one is 55 degrees, or the straight lines you just had if you label it 55 degrees. What will angle 2 measure? Yeah, the same thing, right? 55 degrees. Now, if they tell us over here in 71 that angle 1 is 75, and we know that's a supplementary pair, what does that mean they add up to? Zoe, what do supplements add up to? Supplements add up to 90? So, you have a 50-50 chance, right? But try to get these seated in your memory. Complement, right. Remember, complement, right. It's a right thing to do. So, supplement adds up to 180. Okay? So, what should angle 2 be? Get to the 80, then put the 100 on. Yeah, 105. If angle 1 and 2 down here are complements, and this is 27 degrees, then Allie, what are they going to add up to? They're complementary. To complement someone is the, 90, right? So, get to 30, then get to 90. So how much to get to 30? 3 more. Then how much to get to 90 from 30? Yeah, 63. And Emma, if these are supplementary, now remember we said they don't have to be connected. These are not adjacent, but they're supplementary. If this is 30 and these add up to 180, what should angle 2 be? They're supplementary. So get to the 80, then add 100. What needs to add to 30 to make 180? Back yourself down. 150. Because 30 plus 150 makes 180. Alright, that's all the time we got for today. Thank you guys very much. Please do your homework. I am randomly collecting one of our homeworks this week. Please do your homework. I'm randomly collecting one of them.